management. Right? So I'm on slide number 14. I just hope that the slides have been transitioning correctly. On slide 14,
yeah. Sudeep, are you
we
there?
are talking about how I can do my incident technology. For example, slide number 14. Hello, Gaurav?
Yeah, you are on slide number 14. The voice is a bit disturbed. Can you? Hello?
Hello?
Yeah, it's fine now. Please.
Am I okay now? Okay, sure. Thank you. So on the incident management, what we really want to say is that a security incident handling is not same as a server downtime handling, right? We really need to be looking into things like what was the risk analysis, what was the impact analysis, who all, we should be in a position to share that information with others. We need to be able to, if we are running a 24/7 operation, then we need to be orchestrating all our L1 and L2 resources from the SOC to be talking to the L1 and L2s of the network and the server teams and the application teams, etc., etc. Plus, we need to be also in a position to take these information and map up, was there really a business impact? Was there really an issue with the services which I'm providing to my end customers? So to be able to bring in this business context, to be able to bring in the other stakeholders within the organization into the incident management process, we built a platform where we can have all of these cases to be handled, which we call as the RSSECOps, which allows me to build the business context across all the IT incidents that I have identified, and then allow the case to be managed in terms of how the executives of the organization would look into it, how the IT people would look into it, how my external stakeholders would look into it, and how do I really define whether my SOC or SOC is really functioning the way it should be functioning. Can I report on the dwell time that I have seen in the last 1 year? Can I report on my response time? Can I report on my time that I have been spending on my incidents? Can I report on how valuable each of the components that I have identified in terms of gaining visibility, whether the audit trails were really making things sufficient for me? Was it my network packets that were making life easy for me? So all those metrics around how useful all these controls and all this monitoring that I have been doing, are they really useful? Are they really playing the part that they should be playing the part? So so this particular platform that we talk about in terms of RSSECOps really is the dashboard, is the management platform, which could be just simple IT reporting as well as the business and the process reporting that we need to do to make sure that we understand how our SOC is performing. Right? So that's how we go ahead and address those 4 requirements of visibility, analysis, intelligence, and incident management. So when we put together all of these different components, we come up with what we call as the security analytics architecture, which is on slide number 15. So if you see in this, we have visibility in the form of packets, which is the transactions, actual data that is flowing over the network, the logs or the audit trails that are being generated by all the different systems, the net flow information, which allows me to understand how the data or how the network packets are flowing within my organization. And then once an incident is really happening, it is primarily an endpoint that gets compromised. So what is the state of that endpoint? How are the malware, or how has the compromise affected the behavior of the end system that actually has been compromised? So all of these data is put together into one analysis engine, and I run those analysis. I detect them using my traditional SQL queries. I can also use my big data capabilities in the form of Pivotal that we have tied up with, as well as Hadoop that we support today to run my big data queries or my predictive analytic queries around around the data that I've captured. And looking into the compliance requirements, we also need to be archiving these data. We need to be able to look back in time if I have to recreate a whole thing. So that is where I allow my archiving system to store long-term data, my detection to do my real-time analysis, and my pivotal system or my warehouse system to be able to predict that something might be going wrong. This looks like we are moving into a direction where we will get compromised in the near future. Things are not looking very good. So that is where the warehouse can find out patterns and warn me of these patterns as we move out. Right? So that's the security analytics system that first captures the data, enriches the data with my business context. For example, I could go ahead and look into an audit trail which says that this is the source IP and this is the destination IP. I could actually enrich that destination IP and say this destination IP creates a domain name which actually got created just a few hours back. That's suspicious. If the source, if the destination address is a well-known domain, for example, it is going to google.com, I might be a little less, interested in terms of incident. But if it is completely unknown domain which just got created a few hours back, which means something really different is going on. So that's what we call as enrichment data or the contextual data of that. And we use that data because once we are looking into that IP address few days down the line, that IP address may not have got mapped to any domain at that point of time when I'm doing analysis. So it becomes important that I do enrichment of that IP address with the context at that point of time. Similarly, like a desktop IP address needs to have a context of who is logged onto that desktop at that point of time, so that 1 week down the line or 2 weeks down the line, I'm also able to correlate that this IP address which took part in a particular attack was being used by so and so at that point of time. Right? So the data enrichment really happens at the capture time, and that enrichment data is available for me while I'm doing my analysis, while I'm doing my detection. And all of these is fed by what we call as the RSA Live Intelligence, which is the first watch, the rules that I write, the different kind of reports that I can run. That is streamed into this information to ensure that they are always up to date, they are always relevant of what I'm doing. So that's the security analytics architecture, which primarily builds the heart of what we call as the risk-based approach for advanced SOC. So the risk-based approach is what makes it advanced. What it is allowing me to do is take all the different sets of information. That is, the logs information tells me that yes, something happened, somebody logged in, somebody created a session. That information, when I couple it with the packets, which tells me this was the actual transaction that happened, right? So there was this firewall connection, and this was the transaction, this was the HTTP session, and this was the content of that HTTP session which generated that particular log. And once I look into these and look into these two data, and I see that, okay, this sequence of things most probably is an attack, I can go ahead and say that, okay, if this was the first source IP from where the attack happened, what all happened from that source IP within the organization? So the net flow can actually tell me how the attack was distributed within my organization. So the packets is what I'm just seeing at the, in my interesting network segments, but in all the other segments, what was the behavior impact of it? The net flow information can give me that information and see that, okay, this is how the whole thing had spread. And once I have identified that these were the systems that were a part of this whole attack, I can now deep dive into the endpoint and then see how the endpoint was really affected. Do my analysis, do my malware analytics, see the data which got compromised, the data that was moved out from the endpoints, visualize the endpoint information as well. So all of these, I will move forward into the levels of identification based upon what we have identified as a risky activity across all of these different data points that I just talked about. Right? So the overall RSA critical incident response solution is built around these different aspects that I just talked about. We have the security analytics, which is the heart, in which I am identifying the packet, the audit trail, and the net flow information, feeding it into an event stream technology or a big data technology or the traditional query technology to identify, storing it for my long-term purposes, reporting on them, doing my malware analytics on them, doing my compliance reporting on them. And then once I have identified these data, I correlate or I prioritize that data based upon the data sensitivity that I have seen. So that is where the RSA data discovery or the RSA data loss prevention system allows me to identify what were the sensitive data that took part within the thing. And that when I'm doing an incident response, I go ahead and find out what is the kind of incident control that I should be doing. Which are those systems that I should be quarantining? Which are those systems from where data might have actually got leaked, and what is the data that might have got leaked? Are they still infected? Are they still lying dormant? So that is where the RSA ECAT system allows me to delve into the endpoint and look very, very deep, very, very granular into every process, every data that is sitting within that endpoint and those compromised endpoints.